I'm going live on FB. Okay, so I'm now live on FB. Okay, guys. Okay, so today we're going to talk about survival analysis. This is my own set of slides, so I should be okay. Uh, okay, is there a set of slides for survival analysis by Lee Nang? Yes, there is. It is available. You can ask your seniors. I did not attend his session for the survival analysis, so I don't have Prof. Lee Nang's notes on survival analysis. But since I've been covering this topic for quite a while, okay, so I also have my own set of notes. Okay, so I'm going to cover this survival analysis. Okay, first key point. When we say survival analysis, it is not an analysis of how many people who survive a catastrophic event. Okay? It is not as though you have the nuclear bomb exploded in middle of Kuala Lumpur. How many survive from that nuclear blast? Okay, this one when they talk about survival analysis, they're saying that how is how much is the time from the point of interest until the event of interest. Okay, so contohnya, for example, we are talking about vaccination for COVID. Okay, vaccination for COVID. By right, all those who are vaccinated for COVID are immune from COVID infection. So everybody, including the Perdana Menteri, the Prime Minister of Malaysia, Muhyiddin Yassin, has been vaccinated. Okay, for example, okay, Muhyiddin Yassin was vaccinated yesterday. Izzat Anwari shared his picture on Facebook. Uh, so you can see from that point in time, everybody has been vaccinated. Then we follow up all these people who have been vaccinated. Did anybody develop the COVID disease? Okay, so the survival analysis, the exposure is the vaccination. Okay, the recruitment point is the vaccination. Then the event of interest is developing COVID. So how many people who were given vaccination develop COVID? That's one issue. But here the main point of interest is how what is the duration of time when they develop the COVID. But of course, that is not really a good example. Okay, let's talk about infertility. Infertility is now a problem, okay, among the younger generation. Why? I don't know. If you talk with Prof Hasni said it is related to the pollution around us, the heavy metals. If you talk to uh, the male fertility expert, they may say, "Oh, it is the tight genes causing you to be infertile." You talk to the anti-bicycle group, and the anti-bicycle group say, "Oh, you ride bicycle, that's why you become infertile." Okay, so all these people who are infertile, they enroll into the fertility clinic. They join the MAC. Okay, what is MAC? Not the makeup one, medically assisted conception. Okay, so a survival analysis for that kind of case is when they enroll, that is the time of recruitment. When they become pregnant, that is the end point of interest. Okay, so that is the survival analysis when we talk about here, not the surviving the Holocaust, surviving the Chernobyl blast, surviving the COVID-19. Okay, it's something different. Okay, so as mentioned just now, survival analysis is a set of analysis. Survival analysis is a set of statistical tests that analyzes the duration of time till the event that we are interested in occurs. Okay, till the event that we are interested in occurs. Okay. Sorry, I got problem here. Okay. I do not know what is going on with my screen, but it seems to be the correct one. But my Facebook is frozen. Okay, but never mind. Let's not worry about that. Okay, so the time that you measure can be in years, can be in months, can be in weeks or days, or which is also known as survival time. So that's the thing that you measure. That is the survival time. Okay, I see the problem now. All right. Okay. So okay, right now, I don't know how to move this forward. Never mind. I press enter. Let's see if it works. Okay. So there are many survival tests. One of the survival tests is life table. The other one is Kaplan-Meier analysis. And then we have the Cox regression. And the Cox regression with time-dependent variable. Life table, I'm not going to cover. Life table, I'm not going to cover. Why? Because under population dynamics, they will cover the life table. Under population dynamics, they will cover the life table. So there is no point of duplicating this thing again. Okay, so what I will cover Kaplan-Meier. I will cover Cox regression. So Cox regression will be next week on Tuesday. Okay, next week on Tuesday. Uh, okay, so don't worry. So today we're just going to cover the basic about survival analysis. Okay. So what is the event of interest? The event or the endpoint that is of interest to us could be death if we are studying death. Okay. So example. Okay, you have the Chernobyl disaster. So you expect people to die from the radiation poisoning. So from the point of exposure, the Chernobyl nuclear reactor has a meltdown. So from the meltdown point in time where everybody was exposed to radiation, you follow up everybody who was exposed and you see how long they survive before they die. Okay, so that's the duration of interest, and the endpoint of interest is death. Okay, or developing the disease. Okay, okay, you have an Ebola virus outbreak happen because suddenly the virus was released into an area where there's a lot of people. You follow up all these people, and how many end up developing the disease? Ebola. So right now, our interest is the duration of time from exposure until they develop the disease. It could also be on convalescence. For example, you treat patients with leukemia. Okay, you started them on chemotherapy. You started them on all these new method of treatment. You give them cell therapy, cell therapy. Then they have a period of convalescence. Okay, so how long they had this period of convalescence before they have a relapse? It could be for cure. It could also be from relapse. So throughout the natural history of a disease, all of this can happen. You can have death, you can have disease, you can have convalescence, you can have recovery, you can have relapse. Okay? But when you do the analysis, you just take one of the event of interest. You just take one of the event of interest and you run the analysis. Okay, so as stated just now, it could be, since it is a time to event, it could be time to cure, time to death, time to pregnancy. So time to pregnancy will be those who are coming to see my brother-in-law, Prof. Zainul Rashid. to get treatment for infertility. Okay. According to his Syaran Perdana, the problem of infertility is not limited only to ladies. It could also be due to guys. Guys who have been naughty in their younger days, you may have had a gonorrhea infection, and the gonorrhea infection could block your vas deferens from the inflammation, and then you become infertile because because your sperm got stuck inside your vas deferens. So if that's the case, then you need to see people like Prof. Zainul Rashid to be treated for your problem of infertility. Okay. So what is the advantage of doing this time to event study? You end up with more information than just looking at the outcome, dead or alive, yes or no. The other thing is not all people have a terminating event. Okay. Because you follow them up, they did not reach the endpoint, so they have a censored. They have a censored data. Okay. So let's look at the meaning of censored. So censored data is an analytical problem. Occurs when you do not know the survival time accurately. Okay. Why? Because when you do a study, you're limited to a certain time duration. Okay. You have for master's program, how long you have? If you're doing the next semester's project, you have less than 3 months from data from coming out of the program. So you do not know when is the survival time accurately. Okay, because your short time of study, so maybe that person will reach the end point, but they will reach the end point after the period of the study. Okay, so therefore you have a problem of censored data. Some of the data is lost to follow up. The respondent got sick and tired of seeing your face. So what does he or she do? After you follow him up a few times, he or she move to another place, change the phone number because he or she is tired of seeing you. So patient sample is lost to follow up during the study period. Or the patient died due to death when death is not the end point of being studied. Example, you were doing a study on patient uh, having SGA or not, having babies who are small or normal size upon delivery. But as you are following up the patient throughout her pregnancy, the patient died due to motor vehicle accident. Okay, so so the patient did not reach the endpoint. Patient did not reach the endpoint. It is censored data because she died before she managed to deliver the baby. Okay, so that's the point. So here are some example of censored data. So if you look at this diagram, A reached the endpoint. You see that round thing. The round thing is reaching the endpoint. A reached the endpoint. B did not reach the endpoint. Okay, because they at the end of the study, the patient still have not reached the endpoint. Okay, C. Okay, I think I see the problem. Okay, there's a line here. Okay, okay, let's show you the line. Okay, this line is the endpoint. This line is the endpoint. I cannot see the line here on my small screen, but on the big screen I can be seen. This one is right in the middle of study. This one is the start. So you can see if at the start you have it and you reach the endpoint before the study is ended, then you're okay. You have the endpoint, therefore you do not, it is not a censored data. For B, they proceed all the way to the end of the study. After the end of the study, still no endpoint. So still no endpoint means it is right censored. Why right censored? You do not know the accurate time when patient will develop the disease. C, they started, then they cabut lari and they withdraw from the program. So you have right censored data. Why? Because you do not know whether he or she will get the endpoint and when. D, they come in the middle, but till the end of the study still have not reached the endpoint. E, patient lost, lost for good, cannot trace, so censored data. F, they started late but still reached the endpoint. Okay, so that is what is meant by censored. So you have people who do not reach the endpoint within the study time. Okay, so here's the example given to you. So since only A and F reach the endpoint, only A and F reach the endpoint, so we code the A and F as 1 and 1. So A and F is 1. B, C, D, E, because they did not reach the endpoint, we code it as 0. So these are censored data. So the survival time is very much dependent. The survival time is very much dependent on the duration of time between the start and the end of study. Okay, so from the start when they were recruited to the program and they reached the endpoint, or when they did not reach the endpoint and when they were last known at the last follow-up. Okay, so by right, okay, oh, I just remember, forgot. You can also have, usually we have right censored, but sometimes you can also have left censored. We will discuss that later. So survival time must be larger than 0. Okay, so it should be equal or larger than 0 because it has to be positive. You cannot go back in time. Not this is not end game. Okay, going back in time. So survival time, the value is should be positive. It should be equal or larger than 0. You code as 1 if the endpoint is reached. You code as 0 if patient survived till the end of the study, patient lost to follow up, or patient withdraw from the study for whatever reasons. Okay, so that is coded as 0. They were lost to follow up. Okay, Abdul Aziz Harith posted, I'm here. Okay, welcome Aziz. Okay, he's going to do his PhD overseas. Lucky boy. Okay, so right censored, simple. As mentioned just now, it could be lost to follow-up, could be withdrawn from study, or study ended without the patient reaching the endpoint. So most data are censored to the right. But sometimes the data are censored to the left because we do not know when the patient have the inclusion event. For example, the survival of HIV patient. HIV patient, we only know that they are positive after they are tested with HIV ELISA. So after they tested with HIV ELISA, we know that he or she is positive for HIV. But before he was tested, we do not know how long he has been HIV positive. Okay, how long he has been HIV positive. So that is why we are not sure. Therefore, it is what we call the left censored. So that is what we call the left censored. Okay, so what is the aim of survival analysis? The aim of survival analysis is to estimate the probability of surviving to a certain time. So we will calculate the probability. It compares survival in different patient groups. What's going on right now? Okay, Wafa send message. Okay, don't worry. She was worried I was a bit slow coming up with the link. All right. So the aim of survival analysis is to estimate the probability of surviving to a certain time. So we compare survival in different patient groups. Okay, for example, we can if we're doing survival analysis for developing COVID. Okay, we have two groups of patients, one who were vaccinated and another who were not vaccinated. Okay, how long is the period of time before they develop the disease? That one way of using survival analysis. Or patient who practices SOP fastidiously, always wear mask, washing his or her hands, compared to the group that don't care. Don't wear mask, they just go everywhere without washing their hands, and see how long before they develop the COVID disease. Okay, so that is compare the survival analysis in different patient groups. If you do cross regression, you can do what we call regression analysis to determine which of the risk factors has an effect on the outcome. Okay, has an effect on the outcome. All right. Okay. So Shawal said, can we share? I just say proceed. Uh-huh. Okay. Okay. So please take note. Please take note. The Kaplan-Meier approach assumes that the event only occur at the time when they are observed. Okay. So this one, I'm not going to worry about that. We're going to show it to you all how we calculate the analysis. Okay. So we estimate the survival curve using this method. Okay. So here you may not be able to see this, but I'm going to demonstrate the non-parametric survival plot for parathyroid cancer. Okay. So basically, we have people who were operated upon for parathyroid cancer. They were given treatment. It could be radiotherapy, could be chemotherapy, could be surgical. Okay. So then we follow them up after the intervention, how long they survive before succumbing to the disease. All right. So there's a formula for that. Okay. And the formula looks like this. Okay. One of the difference when I teach, I tend to show them how the value is derived. So how the value is derived. So when you plot the survival curve, you plot the curve at different points in time. You plot the curve at different points in time, then you will calculate the proportion survival at the point in time. Okay, so you have the number alive at the time and the number sorry. Okay, so it's very hard to say like this, but the formula is proportion surviving at time t is equal to the proportion surviving previously, the previous time, okay, t minus 1, okay, times number of life at time t divided by number of life and dead at time t. Okay, so I'm going to show you the example data. I'm going to show you the example data. The example data looks like this. Okay. Okay, this is where usually I demonstrate on Excel. Why not bad? Because the notes I opened up just now is running on Adobe. So because it's running on Adobe, I cannot copy and paste. Okay. So the value is 2, 2 star. The star means censored. The star means censored. 3 star. 4, 4, 4, 4 star. Okay. Again, I repeat, the star means the data is censored. 5, 5, 6 star. Okay, so this is the data set. So this is the data set. I'm going to copy this data set, Control C. I'm going to go and open up Excel. I will share this Excel and I will share the notes on my drtimer.me afterwards. Sorry, I cannot do it now. This time I'm not that well prepared. Uh, Everybody needs this Christmas to catch up with their work, and I'm one of them. And I'm one of them. My mom's birthday was yesterday, and I'm supposed to go back this weekend to celebrate her birthday. Oops. Okay. So we have all these data set. We copy. So let's see whether we can paste it here. Control V. Ah, jadi. Tak jadi. So we have to retype the whole thing. Oh, I got. But not in the format that we would like to have it. First time I kena like this. Usually it's okay. 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 So we have 2, 2, 3, 4, 4, 4. Okay. So we have the time of event here. Okay. So let's put the T here. So this is the T. Okay. So here we have the time. The time is at time 2, time 3, time 4, time 5, time 6. Okay. Now we can close this one. Okay. So how many survive at this end? So the proportion of survive. So we have two formula here. Proportion surviving previously. See? So proportion, okay, t minus 1. T minus 1. So, the proportion surviving previously, t minus 1. Okay. So before they reach the time 2, how many survive? How many survive? Everyone survive. So the proportion surviving previously is everyone divided by everyone. So total we have here, there are 10 data sets. So 10 divided by 10, so it is 1. So proportion surviving previously is, I just realized I can make this thing bigger. So let's make this thing bigger for everyone. Okay. Ooh, okay. Much better. Okay. 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 So next part. Next part, as mentioned just now, we need the data for number of alive at time t plus alive and dead. Okay. So this one is alive. This one is all. Okay. How many people are alive at this point in time? Because this one, you look here, the one who died, only one people died. Only one people died. This one still alive. Okay. So out of 10, 9 was still alive. All the numbers are 10. Okay. So therefore, the survivability S in T, S in T is 9 divided by 10. Okay, you get 0.9. Okay, doktor, tak nampak. Yeah, I just realized that. Haha. So let's push it to the right. Push it, push it. Yay. Okay, much better. I'm too big. Okay, much better. So you can see here, so the proportion of survival at time t is 0.9. So st is 0.9. So you can see here, that is why we get S2 at the time of 2 is 9 over 10 times 1. Okay, 9 over 10 times 1. Why? Because the formula is this one, 9 over 10 times this one. So we have to times this one. Ah, this is one reason why I don't use my old notebook, because the keyboard does not work. Okay, the keyboard does not work. Okay, so this one, this value is the proportion of the time before. So sama dengan this one. Enter. So you get 0.9. Okay. Number of people alive at ni. Okay. This one died already. This one gone. Okay. So this one still alive. This one still alive. So 1, 2, 3, 4, 5, 6, 7, 8. So number of people still alive, 8. Number all dead and alive is also 8. So therefore, this one, the value is the same like above, which is 0.9. So why 0.9? Because nobody died. So for survival analysis, you can only get the survival time if someone reached the endpoint. If someone reached the endpoint. Okay. So let's look at time 4. So time 4 now. Okay, this one is sama dengan the time before. Enter. Okay, maybe I should just do the automatic thing like that. Alright, much better. Okay. So one number of people still alive at time 4. Please take note, this one died already. This one died. This one all gone case already. So we are just looking at this one. So 1, 2, 3, 4. There are 4 people alive. Okay, how many people? There are 7 of them. Enter 7. Doctor, why 7? 1, 2, 3, 4, 5, 6, 7. Enter. So it is 0.51. Okay. For time 5, remember, they reached the endpoint, so they died already. How many alive? Only 1, 6. Okay. So how many total? Only 3. Okay. So 0.17. This one 6, 1 and 1. So it is answer still the same. Okay. And that is how you calculate the survival data manually. That is how you calculate the survival data manually. Ooh. Okay. And I hope, oops. And I hope that's clear on how you calculate the survival data. So this is time point, the time in the point in time. So time 2, time 2 years, 3 years, 4 years, 5 years, 6 years. Okay, this is the proportion of t before. This is number of people alive. This is the number of all the people inside there. And this is how you calculate the survival time. I hope that's clear. I was hoping to use my iPad to calculate manually, but I just decided it's not worth it. Okay, let's not worry about that. Okay, let's go back to the lecture. Okay. So based on the plot, okay, based on the plot, okay, okay, you can draw the survival analysis. So you can see here, okay, you have the line here. Okay, time 2, the survival line dropped to 0.9, so this is 0.9. This time 3 tak boleh calculate. Why? Nobody died. So they follow the same one before. Then we have 4. For 4, 3 people died, there were 7 of them left, so 3 over 7, so you get 0.51. Okay, for time 5, okay, for time 5, there's only 3 of them, 2 died, so 1 over 3, so you get 0.167. Sorry, I mean 0.17. 0.17. Okay, okay, and this one, because nobody died, they follow the same. The third one is the red cross. The red cross indicate there are censored data at this point. The red cross indicate there are censored data at this point. Okay, 0.9. Okay, that is how we calculate the probability of survival. So the probability of survival can be any value between 0 to 1, and the t itself can be any value between 0 to infinity. To infinity and beyond. Okay, I forgot already the name of the... Oh, Buzz Lightyear. Okay, so please take note, the value survival function as in time, the value will decrease over time. When t equals to 0, yes, the probability is 1, because no one will reach the endpoint yet at time 0. Okay, and when the t is infinity, by right, the survival function should be 0, because by right, nobody survives, and therefore the curve turns back to 0. Okay, so usually the aim is to compare. So usually we have the survival function, but the survival function by itself is of no use to us, because there's nothing to compare it with. So therefore we use Kaplan-Meier. So Kaplan-Meier survival analysis is to compare survival curve between groups. For example, in this scenario, we want to test whether the new fractionated radiotherapy treatment improves the proportion of surviving compared to the standard to dose treatment. Okay, so you have the survival diagram. So you can see here, very clearly stated inside the survival diagram. You can see those on the old standard therapy of the 2-dose radiotherapy, they have a much better survival compared to those on the fractionated radiotherapy. Those on the fractionated radiotherapy, they die faster. Those on the old standard treatment, they survive longer. So just by looking at the diagram, you can already see which treatment is better. But of course, you have to prove it statistically. So to prove it statistically, there are many tests. Initially, they had what they call the Wilcoxon-Gahan method. Wilcoxon-Gahan method is basically they take the duration of survival. The duration of survival, okay, they do the Wilcoxon rank sum test. Okay, they do the Wilcoxon rank sum test on the survival time, and then they came up with the result, whether it's significant or not. Okay, so you can do this yourself, the Wilcoxon-Gahan method. Basically, you take the survival duration for the 2 treatment group. You analyze the, the 2 set of data as though they are from a single sample. You arrange them in order, give the rank from the smallest to the largest, then you sum up the ranks for each different treatment group, and that is the Wilcoxon-Gahan method. Okay, please take note, you are taking the original value. So, but over time, they have come up with better tests. because they realize that if we do the uh, Wilcoxon-Gahan method, you're saying that regardless of the the difference in time, you are giving everyone equal weightage. So they decided, okay, instead of doing that, they will have different criteria. So you have the log rank test, where all the time points are weighted equally in this test. Sorry. Hopefully it's not COVID. Okay. I think if I go to the funeral and I started sneezing, everybody will run away. Alright. Better not. Okay. Breslow, the time points are weighted by the number of cases at risk at each time point. So what does it mean? So the early cases, the early time points, when there are a lot of cases who still survive, they are given a higher weight. Towards the end of the study, there are less cases. So those time points are weighted less because there are less number of cases. Okay, so those we take we take note of the weightage to be higher at the start compared towards the end. Okay. For Terranware, instead of taking the by number of cases, they square root by number of cases at risk at each time point. So it is not that much. So when you square root, the number is much less. The weightage is much less. Okay. So that is the difference. So log rank, Breslow, and Terranware. But when you run the analysis using Spss, you get all the answers at the same time. So you don't really worry about that. Okay. So in summary, log rank test, you give equal weight to death throughout the survival time. It's not really death, right? To the endpoint. Equal weight to the endpoints throughout the survival times. Breslow test, they give more weight to earlier death compared to later death. Why? Because earlier death got more cases, more cases, more weightage. Okay. Terranware, because they square root the number of cases, it is somewhere in between the log rank and Breslow test. Okay. So which one to use? The way I advise my student, if your cases at the start they already separated equally, they rated already okay, right now my mouse is right. Okay, if they separate clearly between from the start to the end, then you use the log rank test. Then you use the log rank test. If they come down, they come up again. Okay, so this one you are going to give more weightage to the early part. Okay, so you're going to say the blue line is better than the red one. So to say that the blue line is better than the red one, you have to use the Breslow test, because now they are going to give higher weightage here compared to this one. So higher weightage at the start. Okay. 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 I think I will stop here for the theory, because I'm going to cover COPS tomorrow, next Tuesday. Okay, this one, but in short, COPS regression is similar like logistic regression. They take something that is not continuous data and they convert it to become continuous data, so that they can use the multiple linear regression theory in analyzing this analysis. So Cox regression is another one of what we call the generalized linear model. They are not linear model, but we generalize it so that they become linear model. Okay, so I'm not going to cover these slides. Okay, it's only 1 hour since we started. So what I'm going to do, I'm going to demonstrate a bit on SPSS on how we calculate the survival time. Okay. Right now you're seeing the two pictures of me, the big me and small me. Okay, so I already got SPSS open. Okay, let's close up the other screen. Okay, some explanation about how to calculate. Okay, so right now I'm going to show you on how to calculate the time duration in SPSS, because you will need this for your uh, analysis to calculate the time duration. Okay, so I'm going to demonstrate based only on single data set, not single data set, single data. Okay, so I'm going to put date of DOD, that DOE, date of entry, DOR lah, date of recruitment. Okay, then we have endpoint, date of endpoint, DOE. Okay, so first thing you have to do, this one you have to change to become date. What date you should use? Whichever you're comfortable with. We are Malaysian, we were colonized by the British, our date follow the British style. So it is supposed day, month, year. Day, month, year. So day, month, year, this one. Okay. So here again, I'm going to change to become date, day, month, year. So how we calculate the duration? Okay. I'm going to put my date of being married. So the date of being married is on the 3rd of August 1991. Okay. So I'm going to put today's date. Today's date is the day before Christmas, 24 of December 2020. Okay. Okay. So to calculate the duration of time, there is a special command. There is a special command. Doctor, can we just minus? You can minus, but you end up with the time in seconds. You can minus, but you end up with time in seconds. Okay. So I'm just going to come up with a new variable here. Okay. I'm going to compute. Okay, transform, compute variable. I'm just going to minus directly. So this one, the target variable, I just said the name of the variable, the minus in seconds. In seconds. Okay, minus in seconds. So what happens if you put the DOE, okay, date of endpoint, minus the date of recruitment, you get the answer in seconds. You get the answer in seconds. Okay. So how many seconds have I been married? 927 million 590,400 seconds. Okay. Million, belum masuk trillion lagi. Yeah, not even billion. Okay, so and this one, if you want to change it to become in other format, okay, you have to divide by uh, 60 minutes. Okay, let's say I want to change it to become days. I want to change it to become days. Transform complete variable minus in days. So this one, I'm just showing you the bad way of doing things. Minus in days. So this one is inside bracket. Okay. This one inside bracket. Then you have to divide by how many seconds are there in a day. So inside in a day we have 24 hours. So 24 hours. Inside 1 hour you got how many minutes? Inside 1 hour you got 60 minutes. Inside 1 minute you got how many seconds? You got 60 seconds. Okay. So I click OK. What happened now? I got the number of days that I've been married. So I've been married for 10,736 days. 10,376 days. How many weeks is that? How many weeks is that? So I click analyze, I click transform, compute variable. The same things. Okay, I just minus in weeks. Weeks. Okay. Just now we added so we now have to add 7. Okay, why? 7 days in 1 week. Click OK. So you got, I've been married for 1,533 weeks. But this is not the correct way of doing things. The correct way of doing things to calculate the duration of time, you have to use the command date difference. You have to use the command because under SPSS for the survival time, the survival time should not have decimal point. The survival time should not have decimal point. It should be round numbers. So for it to become round numbers, you cannot use what I did just now. Okay, what I did just now, you end up with decimal point. We don't want decimal point. Okay, so what is the command? Same thing. Same thing. You do the this. Okay, I'm going to change this one. The command to become date, duration. Okay, I'm just going to put duration. Dura in seconds. Habis lah, dura in seconds. Dura in days terus lah. So I'm going to use dura in days. So the command here is date difference. Where to get the date difference? You click on date arithmetic. Then you click on date difference. So you have date 2, date time 2, and date time 1, then the unit that you want. Okay. So date time 2 is the date of event. Date time 1 is the recruitment date. Okay. Then the unit. The unit should be in bracket. The unit should be in quotation mark. So if you want in this, then you type in this. Okay. You type in this. You click OK. So you can see here, you get the same number of days. 10,736 days. Okay. So of course this one is wrong because it should be round numbers, so it should be like that. Okay. 10,736 days. If I want to convert it in weeks, the same command. So transform, compute variable. So dura in days become dura in weeks. So you change the word days to become weeks. Aha. Weeks. Click OK. So you can see now the difference between this and this. Here is 1533.71. This one they just give you the round number 1, which is 1533. So again, as I said, so this is rounded up, you become like that, 153. So that is how you calculate the duration. Using Spss. Okay. Okay. It's almost 10 o'clock. I'm going to cover the kapal maya along with the chord segregation next Tuesday. Okay. So today I think I'm going to stop here. Wah. Fatin Hamimi Abdullah, certified translator, English, Malay, English. Okay. ET calling home. Any question? Okay.
Prof,
Yes, Rahayu.
yang tadi tu, yang Prof demo kat SPSS tu, yang tu kita tak run apa-apa test lagi kan?
Tak. Itu kita akan buat hari Selasa. We are going to cover that on Tuesday. Why we not doing that today? Somehow I lost the mood already. I think although maybe the death happened to a distant relative, but right now on my phone the ding dong about the death, so it's affecting my mood to teach. So I don't feel like proceeding with the analysis yet. Why? Because when we cover the chord regression, we are going to start with the kapal maya first. So there's no point for me to repeat the whole thing. So today I just show you the basic, and the basic is on how to generate the duration. And I tell you, one of the problem in survival analysis is to get the generation of the duration of time correct. I've seen so many other people's notes, and I realized that a lot of people will blur about this date difference command. Many of them are still using the minus thing. Okay. All right. So anything else?
Prof.
Yes,
Sorry,
Farid.
Kalau macam kita nak determine incubation period, kita pakai survival analysis ni ke?
Incubation period masih lagi pakai apa orang kata tu epidemiological curve.
Oh, still epic curve. Okay.
Epic curve. You can try lah. But it won't make much difference. Okay? Boleh try. Should be interesting. Maybe if you can get the COVID data, you can get the incubation period for COVID from exposure till developing the disease. For those who are known to have the exposure lah. Then maybe make more sense. Why 10 days? Why not 14 days? Alright. Okay. Since everything seems okay, I'm going to stop the recording now. Okay. I'm going to start recording now. And with that, we see each other again on Tuesday next week, inshallah. And meanwhile, for those celebrating, Merry Christmas. For the rest of you, Happy Holidays. Okay, thank you. Bye.
Thank you, Prof.
Okay, thank you, Prof.
Okay, now to end the live video. Yes.